In this video, we're going to see how the game of Prisoner's Dilemma relates to one model of oligopoly called Bertrand. So this is actually a model where we just have two firms. So we call it a duopoly, right? Two firms rather than a more generic oligopoly. So we have two firms that in this world produce identical products. So consumers don't really care which firm they buy from. And they compete by choosing their price. So here we have an example. So we have two countries. Those are our players, Saudi Arabia and Iran, and they produce oil. We're going to assume, just to simplify things, that we have no fixed cost, but obviously oil production comes with a big fixed cost. But we're just going to, for the sake of simplicity, say we have no fixed costs, and the marginal cost of producing oil is $40 per barrel. And then we have some total like world demand for oil, P equals 200 minus Q. And each country will choose the price at which they sell oil. So that's the strategy. The strategy is to choose price, which will simplify into a binary choice, but really is a continuous choice, as we'll talk about in a little bit. If both countries set the same price, they'll split the market because consumers don't really care which one they buy from, so they'll each get half the consumers. But if one country lowers their price below the other, then the country with the lowest price gets all of the consumers, right? Because nobody wants to buy expensive oil. So each country has two options. They can collude to set the monopoly price. That's going to earn them the highest possible profit. Or they can compete. They can try to lower their price to capture more of the market share. So within this example, we want to determine what their payoffs are for each of these different options, analyze the game to see how we will predict the firms will behave. So monopoly price setting, where both firms behave together to collude to set the monopoly price, will earn the firms the most profit. So let's examine that outcome first, okay? So what would happen if this market is served by monopoly? So we've got our demand is 200 minus Q, and then our marginal revenue is going to be 200 minus 2Q. And then we would set that equal to our marginal cost, which is 40. So we get 160 minus equals 2Q. So the monopoly quantity here is 80. And then the monopoly price, 200 minus Q would be 120. All right, so here is the monopoly profit maximizing price and quantity, which is going to yield the most profits possible in this market for these firms. So if they collude to set the monopoly price, practically that means they're going to set a price of $120. And how much profit will they earn? So let's calculate monopoly profit. All right, so that's going to be total revenue would be 80 times 120 minus, we have no fixed cost, and then we have a marginal cost of 40. So we do 40 times 80, no fixed cost there. And so we're going to end up here with $6,400 in profit, which if they split equally, would be 3,200 per firm. Okay, good. So if they collude to set the monopoly price, sometimes we call that forming a cartel. Okay, a cartel is a group of firms that coordinate their pricing to behave like a monopoly. If they collude, if they form a cartel, they set the monopoly price, they're going to earn $3,200 each. Okay, their other option is to compete, to lower their price. And obviously there's lots and lots of different options to lower price, but we want to simplify this analysis. So we're going to just pick one alternative lower price. So let's say that they could lower their price to 100. So they can collude to set the monopoly price, or they can compete by setting price equal to 100. So if price is equal to 100, then how much will the consumers wish to buy? Q would equal 100. Okay. So this is collude. Here, this is compete. And how much profit will there be? Well, we've got 100 times 100 minus 40 times 100, which is going to give us 6,000. So you can see, right, if we don't set the monopoly price, there's less profit overall in the market. But that can potentially go all to one firm. So we want to fill in, so if they split that, they would each get 3,000, but if one firm captures the whole market, they're going to get 6,000 in profit. Okay, so we've got our players, we've got Saudi Arabia and Iran, we've got our strategies, right? Collude, set a price of 120, compete, set a price of 100. And we've got our outcomes now. We've got the profit earned in each situation. So we can fill out our game matrix. All right, so if both firms set price of 120, that's the monopoly price, then they're going to each earn $3,200 in profit. And if they both set a price of 100, they'll each earn $3,000 in profit. If Iran sets a higher price, but Saudi Arabia sets a lower price, Saudi Arabia is going to capture the whole market. They're going to earn $6,000 in profit, and Iran will earn nothing. And if Saudi Arabia sets a high price, but Iran sets a price of 100, then Iran will earn $6,000 and Saudi Arabia will get nothing. All right, so now that we have everything in the game matrix, we can start to see that this situation is analogous to Prisoner's Dilemma. It is a Prisoner's Dilemma game, just like the game that we did in the last video. So if I think about what is Iran going to do? Well, Iran doesn't know what Saudi Arabia is going to do, but they can think about each state of the world. So if Saudi Arabia chooses to collude, then Iran, so I'm going to do these in different colors. So Iran will be red here. Iran is better off competing. If Saudi Arabia decides to compete, then again, Iran is better off competing, right? 3,000 is bigger than 0. So Iran has a dominant strategy to compete. Now, we look at Saudi Arabia's problem. This game is actually symmetrical. So Saudi Arabia is going to have exactly the same situation here, but we'll just do that. We'll look at Saudi Arabia's choice. So Saudi Arabia can choose to either collude or compete. Saudi Arabia does not know what Iran is going to do, but they know that if Iran chooses collude, that they will earn a higher profit by competing, right? 6,000 is bigger than 3,200. And if Iran chooses compete, then again, Saudi Arabia is better off colluding. 3,000 is better than 0. So no matter what Iran decides to do, Saudi Arabia is always better off competing. So same. And the Nash equilibrium then is compete. You can see that's the box here where both outcomes are underlined. That's our Nash equilibrium, and the outcome that we would expect from this game. So what does the Bertrand model of oligopoly tell us about behavior in these sorts of markets? It tells us that although firms would be better off colluding and setting the market price, there is still this incentive for competition. So just looking at this game, we would expect cartels to be very rare, right? Because of this incentive to compete. So the prediction here about oligopoly is that profit incentives will lead to competition, and our Bertrand Duopoly equilibrium actually occurs where profit is equal to 0, because it's not really this discrete choice between 120 and 100, right? We could set this up where the collude option is 100 and the compete option is 80, right? And it's going to give us the same incentive structure. So once firms begin lowering their price, they always have this incentive to lower price to capture more customers. And that's going to mean that eventually we end up at the point where we can't lower price anymore, which is the profit equals 0 point, which is our prediction for firm behavior in this Bertrand Duopoly situation. Okay, so there is some additional nuance here, because in reality, firms don't just make one choice, collude, compete. They make a series of choices. So they interact repeatedly over time. And when we look at a repeated prisoner's dilemma game where you play the same game with the same person over and over and over again, then this changes the incentive structure a little bit. As opposed to the one-shot game. So a one-shot game, you just play once and then you're done. That's what we've been analyzing. The repeated prisoner's dilemma game is actually quite complicated. Repeated games in general, right? We had to think a little bit more about how to find the optimal strategy, because your strategy of playing can change over time. It wasn't really until we had computers that we were able to simulate these games and then develop our understanding of the optimal strategy in those situations. So in the repeated game, we discovered, actually they had like a big computer science conference, I think way back when computers were simple, where they had a bunch of computers people get together at a conference, and then the computers, they ran different strategies and they all played prisoner's dilemma against each other over the course of like a week, and then they saw which strategy at the end yields the best outcomes, the highest profits at the end, right? So they discovered that the optimal strategy in the repeated game is a strategy called tit for tat, which means like I'm going to give you what you gave me. So in this strategy, you begin by colluding, but then in subsequent rounds, you play your opponent's strategy from the previous round. Okay, so basically I begin by colluding, but then I only continue to collude as long as my opponent is colluding. As soon as my opponent begins to compete, I would start to compete as well. And this optimal strategy gives us some further insight into the behavior of firms in these markets, because it tells us that cartels can exist, and we know that they exist. We observe firms price fixing in, airline markets, obviously in oil markets, but that those agreements are fragile, that as soon as people start to cheat on them, which they have an incentive to do, that those agreements will fall apart. So that cartels probably exist. We know they exist. Cartels can exist, but they will be unstable. And the larger the number of firms in the market, the more difficult it will be to sustain the agreement. Okay, so the larger the number of firms, more difficult it is. Okay, so this really reflects, I think, a pretty accurate picture of how we observe firms behaving in the real world. You should keep in mind that price fixing is illegal. So just in case some of you go out and start businesses, calling up your competitor and saying, hey, like we can both make more money by raising our prices. It's very illegal, and you can get in big trouble for that, and get big fines, even go to jail, right? So don't do that. But it happens. We see in the news all the time that the government is fining the airlines for price fixing, or there was a bread price fixing case in Canada. There's any situation where we have a small number of firms in the market, there's this potential to have collusion, which is really bad for consumers, right? Because we don't want to pay higher prices for the same product just because the firms want to make more money. So anyway, this is not legal, but it does happen, and this is one model to help us understand how that works.